we're going to compare exponential graphs of the form y equals a to the kx now. Now, a to the kx, we know that the k multiplying the x directly inside the function should give us a horizontal dilation of scale factor 1 over k. So let's see what happens. Our reference graph is y equals 2 to the x. So y equals 2 to the 2x. Well, when x is 0, this is still going to be 2 to the 0, which is 1. When x is 1, we get 2 to the power 2, which is 4. When x is 2, that's going to be 2 to the 4, which is 16. When x is negative 1, that's going to be 2 to the negative 2, 1 over 2 squared, which is a quarter, or 0.25. And then I'll do the other values on the calculator. So we've got 2, when x is negative 2, that's going to be 2 to the power of negative 4. And that's 0.0625. And 2 to the negative 3, not that we can really plot that accurately on the sort of axes that we've got. So 2 to the negative 3. Oh, negative 3 times 2, so it will be 2 to the negative 6. So 2 to the negative 6, 0.015625. So, let's see what we can plot. Go through here. We've got 1, 4. And we've got 2, 16. And negative 1, we've got 0.25. And then it's just going to get so small we can't really plot them. So it's going to go through here, up like this. And then it's going to get really steep up here, like so. And it's going to go along here. So this one here is 2 to the power of 2x, and it appears to be doing exactly what we discussed down here. Now we'll do a little investigation like this in a moment using autograph, but the features that remain similar as k changes, well, it's always going to go through here at the same point, because whatever k is, when x is 0, it's still going to be a to the 0. Now, when k is positive, we'd expect the graph to have the same shape, and when it's negative, we'd expect it to come down the other way. So the x-axis is always going to be a horizontal asymptote. It's just that when k is greater than 0, as it is here, it will be the negative x-axis that's the asymptote, and when k is less than 0, not less than or equal to, just less than, it will go along here with the positive x-axis as the asymptote. So here we have y equals 2 to the x as a red curve, and y equals 2 to the power of kx as a blue curve, with at the moment k is 1, so the blue is over the top of the red. I've got the step at 1 here. So if we take k to 2, that's the one we already plotted before, and though it does fit this horizontal dilation scale factor a half. So the blue one is half the distance of the red one from the axis, and that's happening on both sides. It's easier to see on the right hand side. If we go k is 3, it's more extreme. K is 4, and now it's a quarter, and we can see this point here at 4/16 and this point here being at 1/16, so it has squashed in this way so that this one is a quarter of the distance from the y-axis as this one is. So let's take k down. We'll put it to 0, and then obviously we've just got 2 to the 0. Let's look at k being negative. So here, let's put it to -2, -3, and so on. So we can see that we still have this idea of a dilation, but with the negative value we also have a reflection in the y-axis.